So welcome to Introducing AI Pathfinding. In this video we're going to put a nav mesh bounds volume, this green thing, into our world. It looks like this from the 3D view and then like this from the top, and it will work out where you can navigate, where you can't, and we'll be talking about how the AI system is going to allow tanks to navigate around obstructions and take the shortest feasible path to us to come and attack us. Okay, so it's with some excitement that I'm going to introduce you to AI pathfinding. So the first thing really when you are trying to do pathfinding is to firstly understand what pathfinding is. So the concept is that when you need to navigate around something like this big obstruction in the middle of the scene here, then it's not a trivial task to work out how to get from one side of this to the other, especially if it has things like cul-de-sacs in it, i.e. if we were to dig in an area, a bit like this area around here actually, what's to stop the tank kind of going in, trying to come direct towards us and then having to come out? We don't want it doing that. We want it to take what appears to be an intelligent path around this obstruction. And that's where the artificial intelligence comes in. And there's a lot of standard ways of doing this. Unreal is probably using something called A-star pathfinding under the hood, which you can find all about by just having a look on the web for A-star. And you probably better put the word pathfinding on the end, otherwise you'll get all sorts of rubbish. And you can read, starting on Wikipedia, about how this grid-based system works for finding from one place to another. There's a nice little animation right here, actually, which gives you some ideas to the types of calculations that are going on. But let's see it actually working inside Unreal. That would be fun, wouldn't it? So the first thing that you need to do is, and you don't need to follow me through on this because your challenge is going to be to add this thing in, is to add in a nav mesh bounds volume. So just watch me do it to start with, and then in just under a minute I would have thought I will be challenging you to do your own. So under the Modes tab, if you search for nav mesh, or if you want to know where it is another way, you can go to Volumes and then look through until you find nav mesh bounds volume here. You could click the question mark and it would take you to some docs which will tell you all about how that works, and I suggest you probably read those. I'll put these links in the resources for you. So nav mesh bounds volume, we drop it in the world, right? There it is, pretty small. I'm going to scale it, and I'd like you to scale yours as well to 1,000 meters by 1,000 meters. Oh no, that's a bit big for now. Let's go 100. Yeah, 100 by 100 for now, just to keep the speed up, because I don't know how fast your computers are, by say 10 meters. Okay, now you're welcome to follow along, or as I say, in just a moment I'll challenge you to do it. And then what I'm going to want you to do is move it up and down and move it around and see the effect it has. The green things are places where the agents will be able, i.e. the AI tanks will be able to drive, and the red bits, and the bits that are not shaded are places that it will not be able to drive, and the red bits are the bits that it has not yet calculated the navigation mesh for. Now, you won't see this, what I'm seeing on my screen, unless you go to Show and Navigation. Now, there's a P key shortcut for that, so you can click into the viewport and click P, and that will do it. So that's what I want you to do for now. I'll put the challenge slide up. So place your nav mesh bounds volume. Place 100 by 100 meter bound volume in the world. Make sure you have obstruction, brackets S, that's not quite a brackets S, is it? Let's make it a brackets S. Obstructions, at least one obstruction in your world, like a hill, for example. See the effect of raising and lowering that nav mesh volume, like I just did, and have a play with it yourself. And then when you've finished, leave it so that it has a sensible amount of green on the bits where you want your AI tanks to be able to drive, and everything else should be uncolored. And leave the player start and at least one AI tank inside the nav mesh volume. In order for the AI tank to navigate to the player, both the AI tank and the player will need to be in the nav mesh volume in order for it to calculate the path round the obstacles between the AI tank and the player. So go ahead, pause the video and set up your nav mesh bounds now. You may be wondering why I've chosen 100 by 100 meters rather than the whole play space. We'll increase it later. It just takes a long time to recalculate. So let's use a small one to start with. Okay, welcome back. So I've pretty much done this challenge for you. I'm just going to make my screen a little bit larger with F11. I'm going to hit P to bring on the nav mesh display like this. I'm going to try and click somewhere on the edge of the volume so that I can get this up and down control. And notice if you take it down through the floor that you have no valid nav mesh surfaces. And if you bring it up in the air, then because the bottom of the volume is only just clipping the top of these mountains or hills in the middle here, then the only place they could navigate would be on the hills. That's exactly what we don't want. So what you want to do is you want to bring it down so that it maybe can consider navigating the very bottoms of the hills, but not anymore. So that's it. You could make your hills a little bit more interesting. In fact, next time we iterate round to the world, we might well do that now just to give some more interesting navigation qualities. But that's all I wanted you to do there, was create that nav mesh bounds volume. Great. So this is the arena in which things can actually navigate. I'm going to get rid of the tank that slides down the hill, and I'm going to leave us with one tank. Let's just go to the top view, actually. F11, top view, zoom out. And I'm just going to move these tanks. I'm going to have one AI tank here, well inside the nav mesh volume, and I'm going to have another a little bit outside the volume like it is. And what that means is that when we start to explore what happens in terms of the code and these methods, one of these tanks should be able to navigate, the other guy should not. And the player start, of course, where is the player start? Let's take a look. It's here, that's fine, it's also in the inside. Now when you're playing, of course, you can't see that nav mesh, even if you hit the P key. But it is something you can see in the editor. And for now, we will leave it on. That's show navigation. Okay, fantastic. So now that you've seen what a nav mesh volume is, this light green thing, and it's fully calculated, hopefully, on your terrain, it's going to be a good time for me to talk about how we're going to make this stuff work. So we have a tank AI controller, right? We have that class we've made. That inherited from AI controller. Now I'm putting AI controller inside because inheriting from, even though it's a childing relationship, it's a bit like putting a wrap around the outside of AI controller and extending the functionality of AI controller. It's like Russian dolls. AI controller in turn is based on something else and something else. Okay, so the AI controller has a method on it, or one of its parents, but we don't care about what's inside AI controller at the moment. But we know that at the AI controller level, we have a method called moveToActor. And what that does is it moves to a particular actor, i.e. the player. And it also, you'll see later, has another parameter, which is an acceptance radius. It says, we'll move to the player until you get close enough. That's what it's saying. All right, so what this means is that our tank AI controller class that we have actually has that method, moveToActor, ready to use, because it's in AI controller. Now, how do you know that? Well, if you want, the easy way to know that is to buy this course, The Intelligent Thing, and let us do all the hard work. If you want to work it out for yourself, well, then you would go to the AI controller. You go to the header file. You would then start looking at the definition of an AI controller. Now you're in the engine code. You see this tab on the right-hand side with the lock. You also, the Solution Explorer is highlighting the engine. And then you would trawl through a few million lines of code to find out where these methods are and how they work. But I'm going to skip you the pain of that and just tell you that the moveToActor method is the one that we want. Now, on the other side of the equation, we have the tank movement component, which, of course, we have built upon a nav movement component. Now, you remember that we used nav movement component because, let's look at the class hierarchy once again as a reminder, we used it because it was the simplest class that we could use that actually implemented some sort of pathfinding. So if we just start on the class viewer here and turn off actors only, actor component, movement component, nav movement component. And as you hover over these things, you find out that nav movement component's the first one that talks about AI pathfinding, but without the extra complexity and weight of the pawn movement component or anything deeper than that. Okay, great. So that is the nav movement component. Inside nav movement component, if you give yourself the self-flagellation of going through the engine code, eventually you will find that you have request direct move in there, which is a method that does exactly that. It requests that then an actor moves directly towards a particular position. We're going to intercept that request direct move call effectively, and we are going to use it to move our AI tanks. But we're not going to allow the AI to move things in a kinematic way that it would do if we went down the usual path. By kinematic, I mean just moving the actors without regard for the physics on them. So we're just going to do the following. We're going to place our all tanks with tank movement components. I'm looking on the right-hand side here. All tanks are going to be in the nav mesh, actually, but also the tank that the tank AI controller is possessing, not the tank AI controller itself necessarily. Look, when we play the game, and I depossess, you'll find that we have two AI tanks in the scene, right? But the AI controllers just happen to be on the tanks right now. We could move those off the tanks. They'll actually snap back onto them. But I'm just trying to be precise that the tank AI controller is not the tank it's possessing. It just happens to be coincident with the tank it's possessing. But the tank that the AI controller is possessing must be in the nav mesh bounds. That's this green area. And the tank that we want to move must also be in there, which is also the AI tank. But also the tank we want to move towards, the moveToActor, must also be in the nav mesh. So look, what happens is moveToActor, when we pass it the player, it does some pathfinding logic inside the engine. We don't worry about the details. So inside the tank AI controller, we will call a method that is moveToActor and pass the player tank. some magic pathfinding logic will go on, and then each frame, it will spit out a request direct move. It will spit out a vector, a direction in which it wants to move, start moving in order to get from where it is to where it wants to be. So for example, if we take a top view now of our world and go F11, and we put a tank, an AI tank, let's just stop playing because it's a bit confusing with my tank flying all over the place. Okay, so imagine we have this AI tank and it's sitting here, and that my player tank, I'll use the other AI tank as like a warboard, is sitting on the left here. If this tank wants to get to me, it can't go straight over this hill. It's going to go something like this, round the edge of the hill in a fairly natural way. It's easy for us to work out that that's the path. But it's not so easy. You know, we need a bit of intelligence to work that out from the computer. And it's not even easy for us, by the way, when the path gets complicated. You can actually build a maze. And hey, one of you, why don't you build a maze and share it on the community site in the terrain? And that will show that if there's a solution to the maze, the AI tanks will actually navigate that maze. It's pretty cool. But the point is that here is the player position. This AI tank we call move to actor, and the actor is the player. The pathfinding logic works out where to go next and spits out a request direct move vector. That initial vector, the first frame, will be in this direction towards that tip, and then the next frame there, then the next frame there. Then when it gets to the corner, it'll start changing to this way and then this way. Okay, so the request direct move vector is a vector in the direction that the pathfinding wants to go. It's not a line straight towards the player. If it was, none of this would be necessary. It would be very, very trivial to make the AI tanks, well, they wouldn't be AI at this point, they'd be stupid tanks. It'd be very trivial to make stupid tanks go straight towards us, but of course they'd be going right over the top of a hill that may not be possible physically. Okay, cool. So hopefully that makes sense. I'm going to leave the AI tanks in a slightly different place, one off the nav mesh, one just behind the hill. I think I might even move the player start soon, but for now I'd like to be able to see both tanks, and then we'll start moving tanks around the corner. Okay, enough talking about that. That is basically the overview. This is the system we're going to use. In the next video, we're going to implement this move to controller method on the AI controller and the request direct move, and we're going to start thinking about actually getting these AI tanks homing in us. It's going to be scary. So I'll see you in on there. Oops, see you in there even.